All right, here we go for our energy problems. So I want you to use dimensional analysis and scientific notation just so if you run across these numbers on the AP test, they're easy to work with. So I'm going to distinguish between energy and power. Power is a rate, energy is the quantity. Now for the first three here, and this is three out of a lot of different kinds, but these are pretty common, the joule per second, the kilojoule per hour, and the BTU per second. This is how much energy is being used in that time span. Now, the joule, the kilojoule, and BTU are just quantities of energy. Now, it does get a little weird when we get over here to watts. Now, when we talk about the watt or the kilowatt, that is the rate. So how fast it's being consumed. Now, the quantity, and this is again where it gets weird, is the kilowatt hour and the watt second. So, like I said, you're going to have to kind of just get used to that particular idea. Now over here are just some helpful like diagrams. Energy is equal to power times time. You could do, if you're trying to calculate power, it's energy divided by time. Here's just another way to kind of look at it. So again, power is the kilowatt. Time is the hour, and the amount of energy, the quantity used, is the kilowatt hour. So again, here's just again another way to look at the watt, the joule, and the second, and just another way to look at like kilowatt hour versus kilowatt. So again, here the kilowatt hours. So again, kilowatt hour is a unit of energy. The power is the kilowatt, and the time is the hour. When you combine those two, then you get a quantity up here. All right, so taking a look at some of these items down over here, this is just a conversion chart that we're going to need at some point. Again, it's going to be really, really helpful for us. We're going to be needing it for this part here. So I'm going to work through a few problems with you just to give you a sense of how I do them. Again, for these problems, I know, yes, you can use a calculator, and I'll actually use a calculator so I can see what my answer should be and then work it out with scientific notation. Okay, so here we have 20,000 joules, and we want to figure out how many BTUs or British thermal units is that going to produce. So look, let's just run this on a calculator really quick. So we have 20,000, and you want to multiply it by the number of BTUs that 1 joule produces. So let's hop back over to our conversion chart. Here we go. Let's try to find, okay, there's 1 joule is equal to 9.48 times 10 to the negative 4th BTU. So if we have 20,000 joules, we multiply it by 9.48 times 10 to the negative 4th. And normally, I'm probably going to want to put these in parentheses so I don't have to mess with order of operations or worry about that too much. And so that'll give us 18.96. Okay, but like I said, on the AP test, you won't have your calculator to do that. So how are you going to multiply this, 20,000 times, something to the negative 4th, which is a bunch of decimals? Well, first things first, let's convert over to scientific notation. So if you have 20,000 joules, you're moving 1, 2, 3, 4. So 2.0 times 10 to the 4th power. So that's 20,000. So let's write that in here, 2.0 times 10 to the 4th. Now because of dimensional analysis, I want to cancel out joules because I want my final answer. So always start looking for your final answer. I want it to be in BTUs. So I got to get rid of or cancel out joules. So this set of joules is going to cancel out, this set of joules is going to cancel out. So it's 1 joule, okay, and how many BTUs are produced? Well, 9.48 times 10 to the negative 4th. Everything in maths, so kind of a lot of numbers, calculator this and that. It's actually a lot simpler than you think. So you take 9.48, okay, times 2.0 or times 2. That's really all it is, okay? So that is 16, you carry your 1, 8, that's 9, okay? Then 2 times 9 is 18. 2 decimal places, 1, 2, 18.96. Okay, so that takes care of, but again, so you got to be careful because I'm going to do one last part. That was taking this number and multiplying them, okay, because they're across the top. If they're across the top, it's multiplication. If they're across the bottom, it's division. So we got the 18.96 times, now we have to take care of the exponents parts. Since this is a multiplication problem, this turns into an addition problem. So this is 10 to the 4th plus 10 to the negative 4th. That gives us 10 to the 0. 10 to the 0 power is 1. 18.96 times 1 is 18.96. And that's it. You don't need a calculator every time. Like I said, maybe it'll take you a little bit longer, but the math is not that complicated. You just need to make sure you're working in scientific notation, and it'll take care of a lot of your issues. So this is equal to 18.96 British thermal units. And that's it. All right. So let's take a look at the next one. Again, I want my final answer to be in BTUs. So I'm going to go ahead and start writing that. BTU. Here I'm helping you. I'm kind of leaving you these little cookie crumbs or these little breadcrumbs that are going to lead you to the answer. So your final answer has to be in BTUs. Sometimes it can end up on bottom. Most of the time your answer is going to end up on top. So this is a BTU, like that. All right. So normally you work forward to cancel things out. Like the watt hour, I'm going to need to cancel out with another watt hour. Right here. So they cancel out. So like here and here. And over here I'm working with 20,000 watt hours. So if I convert that to scientific notation, I'm just going to do it kind of the fast way because I already know what it is. Okay, 2.0 times 10 to the 4th. Actually, it's the same as that one, 20,000. Scientific notation. Watt hours. I cancel that out, but I need this watt second here, and I need to cancel it out with, well, another watt second. Okay, now I just need to find my conversions, because this is going to cancel out, that's going to cancel out, and I'm left with BTUs. So let's go back to my conversion chart. All right, can I find a conversion between watt hours and watt seconds? Okay, there's the watt hour and there's the watt seconds right there. So 3,600 watt seconds. So let's come back to this one. So for 1 watt hour, that's 3,600 watt seconds. All right. Now, is there a conversion between BTU and watt seconds? All right, let's go back. So BTU. All right, there's a BTU, and there's 1,000 watt seconds. So 1 BTU, actually, let me go back to my paper. 1 BTU is equal to 1,000 watt seconds. And again, this looks a little daunting because it's 2.0 times 10 to the 4th. This one, again, I'm just going to move my decimal over. 1, 2, 3. This is 3.6 times 10. Again, 1, 2, 3 to the 3rd. Okay, and this is multiplied by 2.0 times 10 to the 4th, like that. And then I'm going to divide here at the very end, but I'm going to take care of this part first. All right, so let's go 3.6 times 2.0, so really just by 2. Okay, so that is 12, carry my 1, 7.2, because just one decimal over. So 7.2 times 10, and this is an addition problem, 4 plus 3, so 4, 5, 6, 7. To the 7th. Okay, but then I have this right here. Here's my 1,000. So I'm comfortable enough. I know that my 1,000 is just going to move my decimal around. But if you want to, you can still do this in scientific notation. Okay, so look, 1, 2, 3. So this is 1.0 times 10 to the 3rd. Now, because this is on the bottom, this is you're dividing exponents. So this becomes a subtraction problem. Okay. So it looks like this, 1.0 times 10 to the 3rd, because it's divided by. So what's 7.2 divided by 1? Because these are done kind of like separate. So 7.2 divided by 1? Well, it's 7.2. Now this is a subtraction problem. What's 7 minus 3? Well, that's times 10 to the 4th. There it is. Or this will be 7,200 if I wrote it out. Now, yeah, like I personally am going a little slow. The more you do this, the faster you get. But let's check that on the calculator. Let's see what that looks like. So 2.0. So actually, I'm going to keep things in parentheses. 2.0 times 10 to the 4th times 3,600 divided by 1,000. And there you go. Actually, I forgot 1 0, sorry. Because it's 4 places, so 1, 2, 3, 4. That's right, but that one's wrong. I had to put one more decimal. And that's it. Like I said, you don't always need a calculator. And this will be super helpful on the AP exam.